Hey everyone, welcome back to yet another Euphoria Academia past paper video. My name is Ole and I'll be taking you through it. Today we're going to be doing the Mathematics Paper 2 May or June 2023 paper. We're going to start with question 3, which is about analytical geometry. So without a further waste of time, let's get into it. Right, question 3 starts off with a bit of a story and a background, telling us what we need to know, equations of lines, and what points might mean on the diagram that we're given, and which lines are parallel and stuff like that. So all of it is very important. So I advise you to take note of the most important stuff. If it's not indicated on the diagram, I guarantee you should do it on your diagram and it will make things simpler. Alright, question 3.1.1 asks us to find the value of t. Now t is the y coordinate of A, and A lies on the line AF, where the equation is y is equal to minus x minus 11. Now, to find what t is, we're just going to substitute the coordinates that we do have, so the minus 1 as well as the t, to find our missing y coordinate. Alright, so t is going to be equal to, we're going to substitute minus 1 minus 11, and we're going to find that t is going to be equal, that's going to be minus minus plus, that is going to be minus 10. So the value of t is minus 10, which means the coordinates of A are going to be minus 1 and minus 10. Alright, question number 3.1.2, we're asked to find the size of alpha. Alright, now alpha on the diagram is indicated there, and we can see that it's an obtuse angle, and is the obtuse angle of the line AF, and we can see that it's the inclination line, or the angle of inclination of that line. Now that line is negative, which means we're going to have to add or subtract 180 depending on what we get. So without talking too much, let's get into it. Alright, so the formula to find the angle of inclination is m is equal to tan. In our case, our angle is going to be alpha, and the gradient that we do have was given in the question as minus 1, and that will be equal to tan alpha. Alright, now I'm just going to find the arctan of 1 and not minus 1. So let me just write that down. The arctan of 1 is going to be 45 degrees. And this 45 degrees is our reference angle. It's not actually the angle of alpha. Because we do have a negative gradient, that means we'll have to subtract this reference angle from 180. Alright, so let's do that. So 180 minus 45 degrees, that's going to give us 135 degrees, and that 135 degrees is actually our alpha. For question 3.1.3, we're asked to find the gradient of AC to the nearest whole number. So we're still going to use our formula for the angle of inclination. M is equal to tan theta, and in our case we're looking for M, or the gradient of AC, and the tan, well, we're given the angle as 63.43, and that is going to give us 1.99956 8 into the nearest whole number, that is 2. For 3.2, we're asked to find the equation of the line AC in the form y is equal to mx plus k. Alright, now for an equation of the line, we either need a gradient and a point, or we need 2 points. Alright, and in this case, we actually have the gradient and we have the point, which is A. Alright, so let us do that. Okay, so we're going to say y minus y1 is equal to m multiplied to x minus x1, and okay, we're still going to have the y, and then the y1, we said we're going to use the point A, and t is actually equal to minus 10, so we're just going to substitute minus 10, and we have the gradient. We calculated it in the previous question, which is 2, and the x1 is minus 1, so that's going to be plus 1 right there. And after some algebra, we're going to find that we have y plus 10 is equal to 2x plus 2, which will lead us to say that y is equal to 2x minus 8. For 3.3.1, we're asked to find the coordinates of C. Now, C lies on the line AC. Alright, so we could go the long route and try and find the equation of the line and substitute and all that, but the quickest way is to see or use the fact that B is actually the midpoint of the line AC. Right, and we know that it lies on the x-axis, so that means the coordinates of B are actually going to be an x value and the y value will be 0 as it lies on the x-axis. Right, now let's just substitute what we have in our formula for the line. Just to recap, the formula of the line is y is equal to 2x minus 8, like I have it here. Always try and fill in information as and when you go about. Going to substitute 0, that is going to be 2xb minus 8, and we will find that xb is equal to 4. So that means the coordinates of b are 4 and 0. Alright, now that we have the coordinates of the midpoint, we can actually find the coordinates of C using the midpoint theorem. Alright, and how we do that, we're going to say xb is equal to xa, which is the x coordinate of A, plus the x coordinate of C divided by 2, and then yb, being the y coordinate of B, is equal to ya plus yc divided by 2, and we're going to see that as we substitute xb, we found that to be 4, xa is minus 1, and we're looking for xc, that is going to be divided by 2, and after doing some algebra, we're going to see that that's going to be 8 plus 1, that's going to be 9, so xc is equal to 9. Now let's do the y side. Going to substitute, that's going to be 0, ya, that is minus 10, just going to be added to yc, what we're trying to find. 2 times 0 is 0, and if you add 10, you're going to see that yc is going to be equal to 10. So the coordinates of C are actually 9 and 10. For 3.3.2, we're asked to find the size of the angle FED, Fed. Right, now on our diagram, we need to see what exactly we're speaking about, and we will find that that angle that we're meant to look for is this angle right here. That is angle Fed. Right, now with any of these questions, it's always important to just see exactly what we have, what numbers we have, and such things like that. That will help us. Alright, so I can see that we already have alpha calculated, and we can essentially get this part of the triangle, can get that part of the angle, that part of the angle if we use straight line theorem. But how can we get this guy? Okay, I can see that we have a parallel line here and a parallel line here. So if the angle if the angle is there, let's see if we can relate that to any of our parallel theorems. Okay, let me just draw this line so we can just visualize what we see. Okay, all right, we can see that that angle right there is going to be equal to that angle right there, and that will be because of corresponding angles. And how can we get that over there? Oh yeah, we have a vertically opposite angle right there. All right, so now we know how to get our Fed. Let us write it down before we complicate things for ourselves. All right, I think we can start with the vertically opposite and then tell the story from there. Okay, so we know that the angle, what are we gonna call this angle? We're gonna call it, let's call it A, B, E is going to be equal to 63.43 degrees. Why is that? Vertically opposite angles. Angles. All right, now that we have it there, and now I think we'll probably have to call the one angle E1 and the other one E2. All right, so E1, which is going to be this one right here, that is going to be E1 is equal to the 63.43 degrees y corresponding angles. Because DE is parallel to AC. All right, now that we have that one, how do we get E2? Now E2 and alpha lie on a straight line, so we know that alpha plus E2, and E2 will be equal to 180 degrees. I just should have written this in another line, but the reason is angles on a straight line. Alright, so therefore E2, if you do your mathematics, because we already know that alpha is 135. So if we're going to take it to the right hand side, so that means we're going to subtract 135 from 180. We're going to see that E2 will be equal to 45 degrees. Now we have E1 and E2, so E1, alright, plus E2, that actually gives us the angle that we're looking for. And doing some computation, we will find that 63.43 degrees plus 45 degrees is going to be equal to 108 degrees, 0.43 degrees. Alright, for the last question of question 3, we have question 3.4, and it says that we have a point called G, and it's a point such that EAGC in that order is a parallelogram, and we need to determine the equation of a circle centered at G passing through the point B. Alright, so we need the coordinates of G. So that's going to be the center of the circle, and to find the equation of the circle, we will probably use the points, the coordinates of B. Alright, without further ado, let's get into the question. Alright, so we're told that G is a point such that EAGC is a parallelogram, right? So it would be something like this, right? This drawing is not to scale, whatsoever, but this is just for illustration purposes. So we have EAGC, alright? And we're told that that forms a parallelogram, right? Now, what do we know about parallelograms? You know that opposite sides are parallel, opposite sides are equal. So I'll just do this side quickly. Those are parallel. We also know that the diagonals bisect, right? So that means wherever they intersect, they will bisect each other. So they will divide each other in half. I should make that 4, 1, 2, 3, 4, and that will just have to be 5. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. All right, that's what they do. All right, so I just filled in the details of the parallelogram that we're meant to have, and we can see that one of the diagonals will actually be A to C. And when we look at our diagram, we do have a line that goes from A to C, and that is being bisected by the x-axis. So that would mean that E to G is actually the x-axis, and where these points meet will be B. That will be our point B. Now that helps us out, because if we have bisection or anything like that, that means we have midpoints, right? So that essentially means that between E and G, B is the midpoint. Alright, so we just have to find the equation of E and then find the midpoint. We already have the coordinates of B. Then through the midpoint theorem, we can find what G is, and after finding what G is, we essentially have the equation of the circle. Alright, so let us get into it. How do we find E? E lies on the x-axis, meaning that we only do not have the x coordinates details, but we know that the y lies on always going to be 0. Now, the point E lies on the line AF. We're told this in the beginning of the question. And what's the equation of line AF? Well, we're given as y is equal to minus x minus 11, and we will just have to substitute that. And as we substitute, we're going to see that 0 is equal to minus xe, that's what we're trying to find, minus 11. And then after some algebra, we're going to see that xe is going to be equal to minus 11. So that would mean the coordinates of E are actually minus 11 and 0. Okay, like I said, now we're going to use the midpoint theorem to find the points of G. Now, because we know that G also lies in the x-axis, because that's E to G, that's a diagonal that has to be on the x-axis. We know that for G, the x coordinate, that's what we're trying to find, and the y coordinate is 0. So all that we need to do is just find the x coordinate of G. Now, using the midpoint theorem, we know that B is at the midpoint where they bisect, and the x coordinate of that is 4. That will be equal to, now we already have E, all right, and E, the x coordinate is minus 11, and we're trying to find the x coordinate of G. Gonna divide that by 2. All right, when we do some algebra, 2 times 4 is 8, plus 11, that's 19. Xg should be equal to 19, and the coordinates of G then will be 19 and 0. Alright, now we're told to find the equation of the circle. Alright, now we know that this circle passes through B. And what is the equation of a circle? Well, this is the center. So the equation currently, we have it as x minus 19 all squared plus y squared is equal to r squared. Now, finding r, all we're going to do is sub in our point B, because we're told the circle does pass through there. So when we do that, x is going to be 4 minus 19, all of that squared, plus 0 is going to give us r squared. Now 4 minus 19, that is 15, and minus 15, and then minus 15 squared, that is 225, and that will be equal to r squared, which essentially means that when you square root it, our r is equal to the 15. Alright, now the equation of our circle is going to be x minus 19 all squared plus y squared is equal to 225.